Recording.
Okay. So we're going to take 10 milliamps, and we're going to say this data sheet says this diode likes to light up 10 milliamps. And then we look at the data sheet, which has this curve on it, and we figure out at 10 milliamps, it likes 2.5 volts. Awesome. So we know that this wants to be 2.5 volts, right? Okay, what else? So we've got, this is 5 volts. So if this is 5 volts here, and this is 2.5 volts here, what is the voltage across this resistor? Yeah? 2.5. 2.5. Right? Because 2.5 plus 2.5 is 5. The whole thing, the whole string's got to add up. So it's 2.5 volts across this resistor. We're still looking for V equals IR. We're still looking for R. How are we going to do it? Yeah.
So you have 5 volts equals I times 2.5.
So you're saying 5 volts is V.
Yeah.
I is unknown.
Yeah.
And R is what?
2.5.
2.5 what?
Ohms.
But why is it 2.5 ohms?
Yeah, that's resistance.
Of what?
Oh, volts. 2.5 volts.
Yeah, but R is in terms of ohms, right? So that's what we're looking for, is we're looking for R. Yeah.
You want to know the amount of current you want going into the LED.
Right. But we already decided that, right?
So then you look at the curve to see what matches.
Yeah, so we already decided 10 milliamps is going through the LED, which is great. You're absolutely right, because we can use that. We know 10 milliamps is going through that LED. Yeah?
You have to convert the volts to ohms so that you know, so you have like a common measurement across the equation.
Oh, I see what you're saying. You're doing unit analysis. Sadly, volts does not convert to ohms. That's like converting pounds to feet. So these are two different things. Volts equals current times ohms, or amps times ohms. So this is already balanced for units. So you got 10 milliamps flowing through here, which means how much current's flowing through this resistor?
30.
So why do you say 30?
I think someone said, I think it was Sammy, said 40 milliamps is out of an I/O pin of Arduino.
Right, but that 40 milliamps is what it's capable of, not what must come out every time. So how much current do we have going through this resistor? Yeah?
10 milliamps.
Why do you say that?
Because the resistor, it doesn't, I don't think it lowers the number of amps. Instead, it kind of just makes it not all go in at once. It backs it up.
Right. So if you got, remember, current is people running through this doorway from the V equals IR talk that we had. So electrons are flowing through here, right? If there's 10 milliamps worth of electrons flowing through here, where are they going to come from? So like electrons are going from this wire through this diode out this wire. Where do they come from in this wire? Do they come from the air? No, because electrons don't like to flow through air. Where are they coming from? Yeah.
The Arduino?
The Arduino, right? By way of the resistor. Like if you've got 10 milliamps going through this wire, they got to come from somewhere. So they're coming from this resistor. And from the resistor, they're coming from the Arduino. So you've got this whole train of electrons flowing down through all this stuff. Do you think the amount of current that's going through this wire can be different from the amount of current going through this wire or from this wire? Can they be different? Now remember, they're only connected to each other. So let me add, if there were ants on this wire, little ants crawling around, would any ants be able to, any ants that were going on this wire in a flow, would any that are here not be able to cross this? Or not be able to cross this?
No, because how would they get to the bottom
Right.
if they can't pass through the middle?
So if they're going to go through the LED, since there's no other source or no other place for the electrons to go or no other place for the electrons to come from, they've got to go through this resistor. There's only one path that it can go through. So if there's 10 milliamps going through this LED, how much current is going through the resistor?
10.
10. There's nowhere else for it to go, right? So it's got to be 10 milliamps, right? So now if I told you we have everything we need in order to calculate the resistance that we want, what would you say? Yeah?
Solve for I.
Solve for what? What are we trying to find? What's the goal of this whole exercise?
To figure out what the resistance should be.
Right, what the resistor value should be. So what do we want to solve for?
The resistance?
Yeah, the resistance. Yeah, we want to solve for R. The whole goal of this whole thing is to get R. So if we've got 2.5 volts across the resistor, and we got 10 milliamps through the resistor, do we have everything we need? Yeah? So what do you think it is? What am I going to write on the board to figure out what the resistance value is?
5 equals 0.01 R.
5 equals 0.01 R. So you're suggesting 5 equals 0.01 times R. Now why do you say 5?
Because that's the, oh, sorry, I meant 2.5.
2.5, exactly. Why?
Because that's the voltage drop that you want across the resistor.
Boom. So you're talking about really one component here, this resistor. You want 2.5 to match 10 milliamps using whatever value it takes to make that happen. Yeah.
Is 2.5 the drop, or is 2.5 the amount that you need for the LED?
So it's in this case.
I know
both.
in this case it's both, but if you were to do this equation.
Right. So let's just change this up a little bit to make this more clear. So let's say this is 2 volts. Right? How much would be here? 3, right? Because these two need to add up to 5. Right? So we got 3 volts here, so what's this equation up here? Yeah.
3V.
Awesome. 3 volts equals 0.01 times R. And then we can calculate R equals, who wants to do it? Yeah?
300.
Brilliant. Good. So that's how you figure out how you can use a resistor and an LED together to make it work. Good? Alright, I'm going to go over one more topic with LEDs. Not related to this stuff. How do you dim an LED? I got 3 hands up. That's pretty good. 4 hands, 5 hands. How do you dim an LED?
Reduce the current.
Reduce the current. Awesome. Good answer. But if I told you that this curve is not reliable, like one day you might buy an LED that's got this curve, the next day you might buy it, it's got this curve, and the next day you might buy it, it's got this curve. It's hard to do that, right? It's hard to limit the current. And you'd have to figure out a different voltage every time, and then every time you did that, you would have to change this resistance value. That's tough. Let's say we wanted to dim the LED with the Arduino. So we pick one resistor value, and we want to have it, let's say, start from dim, get a little brighter, get super bright, and then go back dim again. And we want to do that with code. Nice. Got some hands on.
I think that you can use the Arduino to do like LED at whatever value. So if before it was at the full value,
right?
then you move it down to much lower.
So I'm not sure about the code that Arduino specifically uses. Do you know?
I don't know exactly the code.
Okay, do you know?
Analog, right?
Analog, right? That would be another way to do it, and that would be a way to drop the voltage. It would drop the current, but I believe this is a...
Or digital.
So digital, right? I don't think this has an analog out. So it would be tricky to do that. Yeah.
So it's like a sort of like an eye trick that they use. I think is that like they flash the LED really quickly, so it seems like it's dim, but it's really turning on and off really fast.
Right. Do you know what that's called?
I'm guessing now. I think it's PWM.
PWM, awesome.
Don't OLEDs do that though?
No, like incandescence. Well, I guess, yeah, at 60 hertz, they get different levels of current because of AC, but it doesn't actually turn off because the wire keeps up and just stays warm.
Yeah, like if you look at video of someone in a brightly lit room, like in slow motion, it looks like the lights are turning on and off extremely quickly.
So pulse width modulation is, if you want an LED to be on, bright as it can be, you just leave it on, right? You turn it on. You give it 5 volts or 3 volts or whatever it wants. The best way to dim an LED, let's say you want it half bright, you turn it on for half the time. And if you do it fast enough, like 1,000 times a second, nobody's going to be able to see that. But the amount of light that it puts out is here is half of this, right? You follow me? So if it's on half the time, the light that it puts out is half, right? So it'll appear dimmer. It's just this is happening so quickly that we can't recognize it because we can only recognize with our eyes 30 or 60 hertz or something like that. So if it changes more than 30 or 60 times a second, then you can see that it's going to be solid. If you want to be sure that nobody's going to know the difference, you do it 1,000 times a second, and then you've got a perfectly dimmable light. That you can easily start it off and go up to bright and then back down to dim. Right? Because you can change how long it's on. If I did like this, that'd be very dim, right? But if I did this, that'd be very bright. Not full, but like 90%. And so this is a trick you can use with LEDs to dim them. So when you're working on LEDs and you want to have a variable level of brightness, you want to use pulse width modulation. You don't want to be fiddling with this resistor value or this voltage value, because those are unreliable ways to change the brightness of an LED. So instead, use pulse width modulation. Now if you just want to set the LED to be like, I want it to be this bright and I want it to be either on or off, then you can fill with the voltage source or the resistor. Probably the resistor, because it's easier to modify a resistor than to change the voltage source. Make sense? Anybody have any questions about LEDs? You guys know everything you want to know about LEDs? Yeah?
So do they work just by like, how are they different than normal light bulbs? Do they work just by like electrons moving through it and then they like get really bright? But isn't that the same way how a normal light bulb works, a condensate light bulb?
So an incandescent light bulb is a thin piece of wire that when you put 120 volts through it, gets really hot.
Yeah.
And when it gets really hot,
It glows.
it glows. And GE got awesome at making lights that could burn for hundreds or thousands of hours. So it's just a piece of metal. It was specially designed so it would burn. And when it burns out, it finally, it acts like a fuse and it's over. And that's why they're only 70 cents at the store, is because it's a piece of glass and a wire. Super cheap, right? Unfortunately, since you're burning it, it's much less efficient. So you're burning something, most of the energy is going to heat, a little bit's going to light. Right? That's unfortunate. LEDs, on the other hand, are a special type of semiconductor. It's a diode that just happens to emit light when you put current through it. And some guy, probably a long time ago, was sitting there playing with semiconductors, and he was like, holy smokes, this thing glows.
But he never found out why.
I'm sure he spent, I don't know the history of it, but I can't imagine somebody's like, I bet I can make it glow if I put this type of silicon that's doped this way and this type of silicon that's doped this way in the same place. I don't know. You can look it up on Wikipedia. I'm sure it'll tell you the whole story. But it just happens that this type of diode glows. And you can get different colors because you can get different types of doped silicon getting together and making different colors. But they only emit light at that one
So
frequency.
how does an RGB work?
It's 3 LEDs in one.
Huh.
Very simple. They can only emit light in that one way. Your incandescent bulb emits a more broad spectrum light. It emits the reds and the yellows and the greens and the blues. It emits them all, so it looks white, but it's really all light combined.
So does that mean a white LED is all light combined?
A white LED is a blue LED that's got some weird something going on in there. And that's why blue and white are so expensive, is because it's not a normal use of the technology. generally likes to leave the LED at a specific frequency. Red, green, yellow, blue. So making them a pure white is tricky. And they started with blue and they went to white. Any other questions? Nothing else? All right. That's everything I want to talk about. So rest of the day, get to your projects, finish up the meetings with the instructors, and we'll be good.